So let's talk about the different types of chemical formulas. The one that I've been showing you is called the molecular formula, okay? There's a simpler version. There's what we call the empirical formula. The empirical formula is a ratio. It gives me the relative numbers of atoms of each element in a compound. And you're thinking to yourself, wait a minute, that's what we've been doing. Kind of. The molecular formula tells me the actual number of atoms in each element. That's what we've been writing on the board, okay, is the molecular formula. It tells me how many atoms are there of each type in our given compound. The empirical formula is just the ratio, just the relative amounts. So take a look at what we have here. This is hydrogen peroxide, H2O2. There's two hydrogens, there's two oxygens. It looks like this. Hydrogen stuck to oxygen, stuck to oxygen, stuck to hydrogen. The empirical formula for this is the ratio of hydrogens to oxygens. That ratio is 2 to 2 or 1 to 1. So the empirical formula for this is HO. The empirical formula is not as good as the molecular formula because all it does is give me the ratio of atoms. The molecular formula is better because it gives me the actual number of atoms. So you might be asking yourself, why would we ever use the empirical formula? Sometimes that's all we can get, okay? Sometimes that's all the information that we have allows us to get. We'll talk about that as we move forward. So that molecular formula is always going to be a whole number multiple of the empirical formula. In order to get the molecular formula here from this empirical formula, we got to multiply each atom by some number. In this case, that number is 2. Sometimes the empirical formula and the molecular formula are the same thing, like in water. That's the lowest ratio we can have. It's also exactly how many of each type is there. One that gives us a little more information is called the structural formula. And this actually shows how the things are stuck together. And that's what I drew for you a minute ago. Hydrogen stuck to oxygen, stuck to oxygen, stuck to hydrogen, like this. This gives me more information. There's more information in that type of formula than there is in the molecular formula. There's more information in the molecular formula than there is in the empirical formula. So why not use the structural formula all the time? Right? It's clearly the best out of the 3 that we got on the board right now. It gives us the most information. So why don't we use structural formulas all the time when we're writing stuff out? Yeah, it's a pain in the ass. We don't want to write that down all the time, right? So we use the molecular formula instead, right? Because it tells me how many things are there. For a lot of chemistry, the structure doesn't matter to us, at least in general chemistry. When we start to get into more complex chemistry, we get into organic chemistry, structure absolutely matters to us, okay? And so in organic chemistry, your go-to is going to be the structural formula. You're going to write structural formulas for almost everything all the time. For general chemistry, we don't care so much about how the things are connected. We just care about how many things are there. So we use the molecular formula. So there are models, right? There are different models, and your book uses this color code, so I want to show you this so when we're looking at things, you'll know what's going on, all right? So we can have 3-dimensional things, so I can draw you a structure like I did before, but an even better thing would be a 3-dimensional model for how the atoms put together. And there's 2 different types. There's the ball and stick model, and then there's the space filling model. So if we take a look here, here's a molecular formula for methane. Here's a structural formula that shows me how they're connected. Here's a ball and stick model that shows me the 3-dimensional arrangement of the atoms in space. And then there's the space filling model that actually shows the sizes of the atoms and what this molecule would actually look like if it were interacting with other molecules. We work here in Gen Chem. You mostly work here in organic chem. Biochem is somewhere in this neighborhood right here. Medicine is over here because they care about what's the shape of the molecule, how much space does it take up, because that matters for what active site on a protein can it bind to, what inhibition effects can it have, what can the drug do. It's all about the shape of the molecule.